Hello and welcome to the Brightics AI Accelerator tutorial series. This is episode number 5, an overview of our Keras framework.
Hello everybody, this is Arash from Samsung STS AI Accelerator team. Today I want to show you a quick demo about training Keras model with our platform. So as you can see, I have our build here and I use the first general purpose CPU session that you can use it to run a distributed in our platform in the backend and use a network of GPUs. So here, for example, I name it Keras test. I create a notebook environment for our test and let it to be created. There are other environments as well, so those are mostly used for single notebook, for example, for TensorFlow, Keras, PyTorch, everything. You just have access of GPU just in the notebook, and you have access to one GPU. You cannot do distributed. But for first one, and that is a CPU type notebook, but in the back end it can distribute it on multiple GPUs. The notebook is a notebook environment created, so I use that link to access our notebooks. So we have in our build we have some sample notebooks, or you can define your notebook. I'm showing one of our sample notebook that has a Keras model in. So here we have all the Keras models. For example, I use the first one. So here we are using the MNIST dataset to train with a simple fully connected Keras model. So I run these cells and explain through them. So first we import our backend, the SBrain needed libraries to use for training. And here we define some iteration for the training. Here our input function, basically for our training, it something similar to estimator, like TensorFlow estimator. It needs an input function and a model function. So the input function, we use the Keras dataset MNIST. So the output of the dataset should be a generator that passing the dataset and the labels in it. So, and we have two conditions for training or evaluation, and both of them output the format of the dataset. And for the images, we should have the format of the dictionary with the keys of the data. So we define this type of input function. For model function, both of these input and model function are compatible with TensorFlow 2.1 with V1 compatibility. So we import these libraries, these TensorFlow formats to be used in the back end here and also here. And in the model function, as we want to do the distribution based on the Horvath distribution, as you can see here, we're also using the Horvath that later I show. We use its optimizer to define the Horvath optimizer. So for Keras model, we define a simple fully connected layer with the input of 28 by 28 for MNIST, and it outputs like a 10 values as one hot encoded for the MNIST dataset. And we create a model, the Keras model, and we output it in this inner function. And in the main model function, as our backend basically working based on the TensorFlow with Horvath, we have to kind of transfer these Keras layers to the TensorFlow. For that purpose. We use feature column of the TensorFlow as an input layer, and then we go through each of the layers of the Keras model and we convert it, or we kind of add it to the first layer of TensorFlow. So basically, in the TensorFlow 2.1, the Keras layers and the TensorFlow layers basically they're the same type. So we can add it to just define each layer after each other, and at the end we reach the logits. Then we use some standard definition of like the predicted classes, and if there is the prediction, or if there is a training or evaluation, what should be done. So how to calculate the accuracy, the labels, and what's the metrics we define. And at the end we want this model function output a TensorFlow estimator spec. So when it outputs it like that, in the back end the S-brain creates the estimator based on this estimator spec and do the training on it. So the user can define whatever training hooks here based on their need in the training step. So and then I run this cell again, and here is the main part that do the training that uses the S-brain backend. So here we define an estimator. So for example, here we use this define model function to create the estimator. We define the name for estimator, this uniquify, and give a unique name for that estimator that we run in this time. If we rerun it, it names a different name tag to it, so these two runs doesn't get mixed up. So the naming is based on the date and the time labels added to this name string. And we create the estimator, we define some hyperparameter like batch size and the number of iteration. The config is how to configure our training. Like there is no parameter server, we put it 0. It means that we want to use forward, and for forward we also have to specify the sync equal to true, and we always have to use the GPUs for the forward. And also here we want to run the evaluation, so we put it true, and also number of the workers 2, and how often we want to report the result in the log, and how often we want to save the checkpoints. We specify it, and also then we again name the experiment and run the experiment. So again here we call the estimator init hyperparameter, the config we created, and we don't do any data splitting, and also the input function we defined. So and here when we run it, so it output the TensorFlow URL, and also waiting for training to be done, and at the end report the model metrics, like how was the accuracy and metric defined in the model function. So now while it's training, if we go back to the dashboard, and we can see the cluster resources. So there are like 4 GPU available in the training job. You see this is the current job is running, so we have to wait for it to we can see the progress here. The status is running. You can see if you just hover the mouse over there, we see the parameters used for it. The model succeeded the training, and also it shows the accuracy and the loss value, and specifies succeeded. And if you look at the log file, this is for evaluation, this is for workers. It says like different steps. If you want to see more details, you can look at the console log. It's specified like all the steps for like closing connection between different workers, and detailed steps what's doing with model functions and saving the accuracy, and also before that it shows like all the steps and loss value in each step and when it's saving, the checkpoints, and how often the reports are specified in the run config. So after that we want to use this model to actually this job to grab the model of it, and when we create this model we can use it for inferences. Again, for inferences we have input function, we have to define it same way, the same mapping, also same image structure with the key of data, and also predicted input function that the user can define whatever type of encoding or decoding, and how to save the decoded result at the end if they want. And by using that model we deploy it as an inference deployment. It creates inference pod in the Kubernetes, and we wait here for about 6 minutes for that pod to initialize and up and running, and then we run the raw predict. So the raw predict is running in the notebook and on the CPUs available to the notebook, and as I ran it already, you can see the serialized output and the classes and probability. These are all based on that output function user defined. And at the end here you can see we shut down this deployment because we want to free up that pod created in the Kubernetes, and we release it, so we shut it down. But the model we created at the beginning is still there, and here we just use the notebook environment to do inferences. But if you want to use the back-end GPUs, we need to run the batch inferences. Again, here we define the input function and the predicted output function, but instead of running the raw predict, we use that model and do submit the inference job with required parameter like input function, output function, model function we defined previously. And here we're defining using the GPUs, and by that, if I run this one, you can see it's waiting. And if you look at our dashboard and go to inference job, you see the new job is initiating. And if you look at the here, the process is completed, and also this is showing it succeeded. Okay, the logs comes up, so it again shows it succeeded, specifying different steps. If you want to see more details, you can look at the console log. Here there is more details. It is specifying, I think, the model, the dataset done loading, and also previous things it's done. So you see all the messages coming to the Kubernetes console coming up here. So, and also as mentioned before, if user wants to output this dataset, this result with whatever format, they can like specify it here. It can be like a text file, pickle or numpy, whatever they want. They can specify here in the output function, and when it's running, the result can be saved in the notebook environment. So that's it for the Keras Forward training. I hope it can be useful, and hope see you again. Thank you.